Hey everyone, this is Dr. Walker. In this video, we're going to go over the third example from video 631 on equations for lenses. This example, we're going to go over a lens maker's equation, especially since we did not cover it in the lecture video. It was just an additional slide. So we're totally going to skip the derivation of this equation. The equation that was provided in the slides was as follows. 1 over f is the focal length, equals n2 over n1. N1 is the surrounding medium, and n2 is the index of the lens, minus 1, times 1 over the radius of curvature 1 minus 1 over the radius of curvature 2. So we use the lens maker's equation when we have a thin lens that might have different radii of curvature. So there's going to be one on the left and maybe a different one on the right. And you could have convex one, and then a concave one, right? You can have different radii. This would be R1 and this would be R2. Well, this is the surface, but this surface has a radius 1 and this surface has a radius 2. Okay, so that being said, let's see how we can use this equation. This equation tells us that the focal length of the lens is going to depend on the two radii of curvature and the ratio of the indices. Now, a lot of time the lens is going to be surrounded by air, so a lot of times the surrounding medium, we're going to have 1 in the denominator, and a lot of books just show this ratio as just n, assuming that we are surrounded by air. Alright, so in this case, we are looking for the focal length, and we are given the refractive index is 2, so that is n2. So we know that n1 is air, is equal to 1. And then we're given the two radii of curvature. We are given a positive one and a negative one. It's good to know what these means because sometimes you may just be given a picture and then you have to figure out what is positive and what is negative. If we go back to our table that we had in this video, and I kind of skipped over this line here because we didn't have the lens maker equation in the video, but this table tells you everything you need to know about the sign convention. If the radius is in front of the lens, then the radius is negative. And the radius is in front of the lens if you have a concave lens, right? Because then the radius is over here somewhere. If the radius is in the back, then you have a convex lens, and that radius is considered to be positive. So as long as we know these sign conventions, we know how to use the lens maker's equation. So in this case, if we have a positive R1, it's going to be convex lens, then a negative R2, so it's going to be a lens like this. Alright, so that being said, all we need to do is plug in the values in order to get our focal length. 1 over f is going to equal 2 minus 1 times 1 minus 20 minus 1 over negative 35. We can leave everything in centimeters, and our focal length will be in centimeters. When we plug all of this in, we're going to get 0.078, and therefore f is going to be the reciprocal of this, and it's going to be 12.82 centimeters. So that's how we use the lens maker's equation. We just have to pay attention to the sign convention for the two radii of curvature and know that the surrounding medium is often air, and so the n on the denominator is often 1. And just to say it one more time, the lens maker's equation is useful because it relates the focal length of the lens to the 2 radii of curvature and to the index of refraction of that lens.